Welcome to today's topic, understanding data storage in computers. Now, let's imagine your computer is like a big filing cabinet where you keep all your documents, photos, videos, and apps. Data storage is how the computer saves and organizes all these informations so you can find it later. It's just like a warehouse where information are being kept for retrieval and for future use. What is data storage? Computers store data in binary, which is zeros and ones, and we all know that the language the computer understands is binary language, which is zeros and ones. Now, storage is like a digital filing system for files, apps, and media. It's a cabinet, it's a locker where informations are being kept for safe usage or retrieval or for future references. Now, the more storage space you have, the more photos and videos your system can accommodate. Now, in the picture, you see the different storage devices. We have the flash drive, the memory card, the hard disk, the CD-ROM, the CD or DVD player, DVD disc that is used to save informations. We can see the floppy disk, you can see the external hard drive. All these are different storage mediums or storage devices. Units of storage in the computer system. Now, the unit of storage, the smallest unit of storage in the computer system is the bit. The bit is the smallest unit of measurement for data in the computer system. Now, bits, the size of a bit is either 0 or 1. An example is a light switch. In our various homes, we have a light switch which has either the off button or the on button, which is 0 or 1. That is a real life scenario of a bit, either 0 or 1. Then byte. The second unit here is byte. Byte is made up of 8 bits. 8 bits makes up a byte. Example here is a letter, A or B or C or D. A letter, one letter is made up of a byte. Then the next unit here is kilobyte. Kilobyte is made up of 1,000. 1 kilobyte is made up of 1,024 bytes. Example of a kilobyte is a small text file. Sometimes when download PDF, you see them in kilobytes. Then the next one here is megabyte. 1 megabyte is 1,024 kilobyte. 1 megabyte is 1,024 kilobyte. Example here, a real life scenario is the music you download online. When you're downloading a song on the internet, you see them comes in megabyte, 5 megabyte, 6 megabyte, 7 megabyte, 8 megabyte. Those are the different storage, the size of the data or the file you're downloading. Then the next unit here is gigabyte. 1 gigabyte is made up of 1,024 megabytes. Now, a gigabyte in the real life scenario, sometimes the movie you're downloading, sometimes we download movie of 1 point something gig, 1.2 gig, 1.3 gig. For those of us that like playing games, Call of Duty, Modern Combat, you see those games in large size, sometimes 2 gig, 3 gig. That is the size of the storage for that particular game or that particular document you're downloading. Then the next unit here is terabyte. 1 terabyte is equal to 1,024 gig. 1024 gig. Now, a terabyte can accommodate a lot of documents because it's usually large, it's usually big. Most modern laptops, sometimes you see them with 1 terabyte. It can store a lot of documents. You can store thousands of photos, thousands of videos without getting filled up. So this is a simple comparison chart from small to large, bit, byte, kilobyte, megabyte, gigabyte, and terabyte. Converting storage units. Computer counts in 1024, not in 1000. Computer works using binary. That means that it only understands two numbers, 0 and 1, and this is called base 2. 0 and 1, which is called base 2. Now, each 0 or 1 is called a bit, short for binary digit. Now, group of these bits is what forms a byte, and from there you have larger storage units like the kilobyte, megabyte, gigabyte, and terabyte. Now, we say computers store a count in 1024 and not 1000. Why? Why does it count like that? In our everyday number system, which is in base 10, we usually count in thousands. For example, 1 meter is equal to 1 kilometer, 1000 grams is equals to 1 kilogram. That is in base 10. It's our everyday numbering system. We count in base 10, but that is not the case of the computer. The computer count in base 2. Now, the closest power of 2 that is near 1000 is 2 raised to the power of 10, which is equal 1024. So that is why the computer counts in 1024. It counts in base 2. That's why you see 1 kilobyte is equal to 1024 bytes. Instead of 1 kilobyte to be 1000 bytes, it's now 1000. 1 kilobyte is equal to 1024 bytes. 1 megabyte is equal to 1002 kilobytes, and 1 gigabyte is equal to 1024 megabytes. Why it matters is when you buy a computer or an hard drive, sometimes it says 500 gig hard drive. Now, your computer does not see it as 500 gig hard drive. Rather, it sees it as 512,000 megabytes. 512,000 megabytes. Why? It multiplies it. 500 gig times 1024 megabytes. Now, we say 1 gig is equal to 1024 megabytes. So in order for us to get our 500 gig in megabyte, you have to multiply 500 times 1024 megabyte, which will give us 512,000 megabyte. Now, there are some companies that counts in 1000 when they are advertising their product. They'll tell you the thing is the hard drive is 10,000 gig or 50 gig, like that. But that is not how the computer counts it, and that is why sometimes you get slightly less space than the one the company is advertising, because your computer counts in 1024 instead of. Types of storage. Now, we have different types of storage in the computer system. We have the primary storage, the secondary storage, and the cloud storage. So I'll just go briefly on each of them. The primary storage which is the main storage of the computer, consists of the RAM and the ROM. The RAM, which means random access memory, stores active program. Now, this type of storage erase when the power is off. When you put off the power of the system, all data that have been held by the RAM is lost. Now, the RAM holds active programs. For example, when you are playing a Candy Crush game, or let's say you are watching a video on TikTok, you minimize it. You are watching a video on Instagram, you minimize it. You are watching a video on Facebook, you minimize it. Now, if you boot your phone or you off your mobile phone and you on it back, those datas are lost because the RAM is just a temporary storage. It holds it for the main time when the phone is on. But when it's off, if you go back to Facebook, now that particular video you are watching, it will not start from there. It will not start from there because it has lost those datas. While the ROM is read-only memory. It's a permanent and non-editable memory. It stores the firmware, which is the boot up instructions of the computer or your mobile phone. That is why if you format your mobile phone and you on it back, it will still boot. Why? Because the firmware, which is the boot up instructions, is still there. You cannot format it. It's non-erasable. You cannot erase it. It's just there. Same thing with your computer. If you format your computer and you on it back, it will be telling you press F9 or F12 to go to the BIOS environment, which is the basic input and output system, where you can get your boot up instruction for that particular computer system. Now, the number 2 here is the secondary storage device. Secondary storage devices, which are used to store data. Example is the HDD, which is hard disk drive. HDD, hard disk drive. Now, it's used to store data or information, pictures, videos, games, but it's usually slow compared to the SSD, solid state drive. The solid state drive is an upgrade of the HDD, which is the hard disk drive. It's an upgrade. The SSD is faster than the HDD hard drive. It has no moving parts. The hard drive, the HDD, which is the hard disk drive, has what is known as clusters, moving parts. But the SSD that was upgraded to doesn't have moving parts. It's faster than the HDD. Then we also have the USB drive and the memory card. They are also part of secondary storage devices or storage mediums. You use them to store data. Your memory card, you use it to store data or information, pictures, videos. Then the third one here is the cloud storage. The cloud storage is an online storage medium that is used to store file. Example is your Google Drive, your iCloud for those that are using Apple products like your iPhone. You have your iCloud where you store your pictures, your videos. They are also classified as storage mediums for the computer. They are storage mediums. Key differences between the RAM, ROM, and the HDD/SSD. Now, when it comes to the features, volatile. The RAM is very, very volatile. It loses data on power off, but the ROM does not lose its data on power off. The HDD and SSD does not lose its data on power off. When you switched off your phone or you switched off your computer, the HDD and SSD does not lose their data. HDD and SSD are used in your computer as external drives or drives. Hard drives in your computer, they are used in the computer. The ROM too does not lose its data on power off. Then another feature which is writable. The RAM is writable. The ROM is not usually writable. You cannot rewrite the ROM. It's not usually writable. It's permanent. Then the HDD and SSD is rewritable too. You can rewrite it. It's rewritable. Then the speed. The RAM is very, very fast. It supports the central processing unit in carrying out tasks. It holds running applications, running software in the system. While the ROM is also very fast, it contains the firmware of the computer. While the HDD is slow. The HDD, hard disk drive, is very, very slow, while the SSD is fast compared to the HDD. The SSD is an upgrade of the HDD hard drive. Now, what are their purpose? The purpose of the RAM is to keep active running apps, saves data, makes apps, those apps that are running, it holds those apps that are running, it holds them. That's why sometimes when you have a system that has a large RAM capacity, it processes data very fast because it can contain different apps that are running on the background at the same time. For example, you can open TikTok, open Facebook, open Instagram, open your Google Chrome and be watching movie, open your gaming stuff and all that on your mobile phone or your laptop. Those things are running on the background. The RAM can hold them without any interruption. Then the purpose of the ROM is for the firmware. It holds those bootable instructions that tells the computer where to boot from. That's why if you format your phone, like I said earlier, if you format your phone and you put it on, you on it back, it will still boot up to that desktop environment. Why? Because the firmware is already there. It's what gives you that interface, that user interface. Now, that of the computer system, when you format your computer system and you on it back, it will take you back straight to the BIOS environment, where it will be telling you to press either F12 or F9 on your keyboard to take you to the BIOS environment, which means the BIOS means basic input and output system. And that point is where your bootable instruction is. It tells the computer where to boot from. Then the purpose of the HDD and SSD is for long-term storage, used to store your data, your videos, your pictures, your games. You use them to store those kinds of information, your documents. It's used to store them for long-term purpose. You can check the video description for practice questions and exercise.